Among the most captivating wonders in the night sky is the approaching supernova of Betelgeuse. Located on the iconic shoulder of the Orion constellation, Betelgeuse is a massive red supergiant nearing the final phase of its stellar existence. In a surprising turn of events in 2019, one of the sky's most brilliant stars began to dim, significantly visible even to the naked eye. Over several months, its brightness dropped so sharply that many observers speculated it was nearing death. Training their telescopes on the giant star in anticipation, astronomers were taken aback by the sudden dimming. Many believe Betelgeuse is on the verge of erupting into a supernova, marking the conclusion of its stellar life cycle. Yet the precise moment of this cosmic eruption and what might trigger it remains uncertain. Could this lead to harmful effects for Earth? This gleaming red star, Betelgeuse, is found at the upper right shoulder of Orion, the celestial hunter. It is also known by its formal name, Alpha Orionis. While it is the second brightest star in its constellation after the supergiant Rigel, it continues to intrigue scientists because of its irregular brightness and distinctive identity. Stars labeled Alpha are typically the most luminous in their constellations. Even though Rigel surpasses it in brightness, Betelgeuse stands out due to its colossal size and striking reddish-hue dot as one of the most recognizable stars in the SR. Night sky. Betelgeuse ranks as the 10th brightest overall and 7th in visibility from locations in North America, Europe, and Canada. Its name originates from Arabic and loosely translates to the armpit of the giant, referring to its position in Orion. This star sheds about 1 solar mass every 10,000 years, ejecting material uniformly in all directions and forming a surrounding nebula. This nebula spans 30 astronomical units, 30 times the distance between Earth and the Sun, and contains mass exceeding the star's own by 250 times. Deep inside, hydrogen atoms in Betelgeuse fuse under intense gravity, forming helium and releasing light and heat. As it exhausts hydrogen, it begins fusing helium and carbon. Once the helium is spent, carbon fuses with neon, eventually forming iron. However, iron fusion doesn't generate energy, leading to a collapse triggered by gravity, which then culminates in a supernova, one of the universe's most dramatic. Outbursts. Stars emit light across various wavelengths, depending on their age and evolutionary phase, ranging from the brilliant blues of youthful stars to the deep reds of aged giants. Ancient astronomer Tycho once described Betelgeuse's color as ruddy, though early Chinese astronomers documented it as yellow, suggesting it may have once been a yellow supergiant. Massive stars like Betelgeuse burn through their hydrogen rapidly, resulting in relatively short lifespans, around 10 million years. There is little doubt Betelgeuse is in its final evolutionary stage. While our Sun still has over 5 billion years left, Betelgeuse edges closer to its eventual explosion. However, no one knows exactly when that will occur. The star experiences 2 periodic cycles of brightening and dimming, each lasting about 5 years and fluctuating for around 100 days. These fluctuations are thought to result from the outer layers expanding and contracting, altering the star's diameter and surface temperature. Public fascination with Betelgeuse soared during its unusual activity in 2019 and 2020, when its brightness dropped sharply before recovering. Some scientists speculated that this dramatic change could hint at an imminent transformation. Historical records dating as far back as the 1st century BC document observations of Betelgeuse, but the cause of its dimming remains elusive. Betelgeuse is traveling through the interstellar medium at roughly 30 kilometers per second after being expelled from its birthplace in the Orion OB-1 association, which includes Orion's belt stars. The resulting bow shock from this movement spans more than 4 light years. Measuring red supergiants like Betelgeuse is notoriously difficult due to various complexities affecting size estimates. Being a pulsating star, its diameter changes over time. Combined with the dimming of its outer layers, this affects its visible color and perceived brightness. Additionally, the expelled shell of matter around the star plays a significant role in absorbing and scattering light, influencing how we see it from Earth. The star's apparent size also varies depending on the observed wavelength, with measurements differing by as much as 35% across spectral bands. In July 2009, the European Southern Observatory released images from its ground-based Very Large Telescope Interferometer, revealing a massive gas plume extending up to 30 astronomical units from the star, equivalent to the distance between the Sun and Neptune. At least 6 such ejection events have been recorded. These eruptions may offer valuable clues about how giant stars lose mass in their later stages, potentially holding the key to their final fate: the intricate processes inside Betelgeuse's extended atmosphere remain difficult to unravel, as does the exact mechanism behind mass loss in red supergiants. These stars are crucial to spreading elements throughout galaxies. Thanks to advancements in interferometry, astronomers are inching closer to solving these cosmic puzzles. In 2019, data from the Hubble Space Telescope and other observatories confirmed that Betelgeuse had ejected a large portion of its outer atmosphere, resulting in a significant surface mass ejection. While our Sun produces coronal mass ejections, Betelgeuse's event was thousands of times more powerful, releasing matter with 400 billion times the mass of a typical solar eruption. This helped explain the steep drop in brightness seen in October 2019. By mid-February 2020, its brightness had declined nearly threefold, from a magnitude of 0.5 to 1.7. By February 17th, its luminosity had stabilized for over a week. On February 5th, it appeared the dimming had ceased entirely. However, this recent dip in brightness was unrelated to an imminent core collapse. Infrared measurements taken on February 24, 2020, showed no major changes. One popular theory suggests the dimming was caused by a cloud of stellar dust from a mass ejection that temporarily blocked the star's light from our view. When Betelgeuse does eventually explode, the supernova will be among the most visually stunning events humanity has ever witnessed. Even though it lies about 640 light-years away, the blast could rival the brightness of the full moon, and might even be visible during the day for several weeks or months. Scientists estimate that this explosion will release more energy in a few seconds than the Sun will emit over its entire 10 billion-year lifespan. The light from this event will travel across space and reach Earth as a dazzling point in the sky unlike anything we've seen before. There's no cause for alarm, though. Despite its proximity, Betelgeuse is distant enough that its supernova will not pose any danger to life on Earth. Instead, it will offer a rare and invaluable scientific opportunity. While Betelgeuse has since returned to its typical brightness, its erratic dimming behavior is still under close scrutiny. Researchers continue monitoring the star using tools like the James Webb Space Telescope, the Hubble Space Telescope, and ground-based interferometers such as the VLT and ALMA. These instruments help track surface brightness shifts, convection activity, and ongoing mass loss, clues to the star's growing instability. Betelgeuse's dramatic dimming may help scientists better understand the behavior of dying stars. As a case study, it could improve predictions for similar events in other galaxies, explain how elements are scattered through space, and illuminate the processes that generate key materials like iron and gold. Essentially, Betelgeuse is a cosmic clock ticking toward an explosive finale. It could erupt tomorrow, next year, or even 100,000 years from now. But whenever it does, it will light up the universe in a breathtaking spectacle and deliver scientific data unlike anything seen before. Studying the birth, life, and death of stars like Betelgeuse is more than academic. It is fundamental to understanding the universe itself. Giant stars act as forges where heavy elements are created. When they die in explosive events, they scatter these materials into surrounding clouds, seeding the formation of new stars, planets, and possibly life itself. The anticipated explosion of Betelgeuse presents a rare opportunity to observe a nearby supernova in unprecedented detail. Most known supernovae have occurred in distant galaxies, making them harder to study. But because Betelgeuse lies within our own Milky Way, astronomers will be able to follow every phase of the explosion and its aftermath with exceptional clarity. This event is especially exciting for those studying neutrinos and gravitational waves. When a star explodes, it releases not only visible light, but also neutrinos and potentially measurable distortions in spacetime. If Betelgeuse goes supernova, detectors like LIGO, Virgo, and IceCube might capture these signals, offering groundbreaking insight into stellar death and the laws of physics. Researchers aren't just watching Betelgeuse for its expected end. Its unique behavior also helps reveal more about how stars function. Red supergiants remain one of the least understood phases in stellar evolution, massive, unstable, and difficult to model. Though technology is improving, many mysteries remain, and Betelgeuse might just hold the answers.